What would the world look like without trucks, cars, and vans? Quiet, peaceful, and clean. But without vehicles, our world would come to a standstill. The car has transformed society like no other invention since industrialization, but is it really the future of transportation? The parcel boom during the COVID-19 pandemic accelerated the energy transition for the last-mile sector. Moconomy takes a look at the current state of the last-mile sector to explore the past, present, and future of electric vehicles. The invention of the automobile allowed modern societies to thrive and grow without depending on long horseback journeys. This new form of transportation revolutionized the movement of goods, people, weapons, and ideas, transforming city infrastructure. It enhanced our quality of life by making access to jobs and services more convenient, and entire economies were built around the automobile. Today, the last-mile sector is transforming our lives once again. The global electric commercial vehicle market size has been valued at $71.04 billion in 2023 and is poised to grow to $405.01 billion by 2031. In Europe, 100% battery-powered light commercial vehicles currently have the highest sales among all fuel types. Across the European Union, there are more than 6.4 million medium and heavy commercial vehicles in use, transporting approximately 13.6 billion tons of freight annually. Moconomy is profiling both small and major players in the global commercial electric vehicle market. Despite Tesla's disruptive reputation, the company is still far from achieving a leadership position in the commercial vehicle sector. Tesla has announced the launch of the Tesla Semi, which has already received orders from major companies such as Walmart, Costco, Cisco, and US Foods. Tesla has a market cap of approximately $713.27 billion. Tesla offers their semi-truck at ranges of 300 miles or 600 miles, with a price difference of $30,000. However, there are currently other players in the sub-market for commercial all-electric delivery vehicles that outpace Tesla. Volkswagen is a German market leader in light commercial vehicles. Currently, Volkswagen offers 3 electric vans. Their partnership with Ford aims to expand in Europe in order to speed up production and reduce the cost of electrifying vehicles. Volkswagen's market cap stands at approximately €56.82 billion. Renault Group, a leading European manufacturer of light commercial vehicles, offers the EasyFlex van and has forged a significant partnership with Volvo and the shipping group CMA-CGM. Together, they are launching Flexis SAS, a new company dedicated to creating electric vans. With Renault and Volvo each investing €300 million, production is set to commence in France in 2026. BYD Co. Limited is a Chinese public conglomerate, operating in the world's largest market for electric vehicles and batteries. BYD and Tesla are the largest electric vehicle manufacturers globally. BYD offers a range of EV van and truck models tailored for last-mile delivery. Currently maintaining major partnerships with companies like DHL, IKEA, Shell, and SXT. BYD is expanding its global footprint. The company boasts a global market capitalization of €92.77 billion. Ford is among the runner-ups in the list of the biggest players on the EV market, with a firm valuation of over $40.47 billion. That's about the size of the entire German market, according to Claudia Voigt, speaker of Ford Germany for commercial vehicles. The E-Transit is the clear market leader in the 2-ton payload segment for electric vans. Last year, it achieved a market share of more than 50% in Germany. However, at 2.3%, the overall share of electric commercial vehicles is still relatively low. The starting price for Ford's E-Transit model is €55,149 on the German market. Ford has formed a partnership with DHL. A notable and historically significant player in Germany is Bion, also known as Street Scooter. This electric vehicle startup was a pioneering force, introducing electric vans for last-mile package delivery in Germany. Its innovative approach led to its acquisition by DHL in 2014, solidifying its market impact. They have since merged with Evolution GmbH. And finally, let's explore a key and leading submarket in the realm of heavy-duty vehicles, trucks. The global electric truck market is forecasted to reach a value of $815.3 million in 2023 and is projected to grow from $1.09 billion in 2024 to $13.05 billion by 2032, exhibiting a CAGR of 36.4%. The Volvo Group leads the charge in the heavy-duty delivery sector, offering the VNR electric truck designed for regional transport. With a range of 275 miles, 440 kilometers, and a 565 kilowatt-hour battery capacity, it can reach an 80% battery charge in just 90 minutes. Currently, Volvo Group's market cap stands at €52.29 billion. Electric vehicles have been around for 150 years. In 1835, the American inventor Thomas Davenport built the first electric vehicle. Electric vehicles were present in many European countries and in the USA in those early years. There were delivery vehicles, buses, lorries, taxis, and even car sharing complete with charging stations. And of course, private cars. Already by 1900, 38% of all cars were electric vehicles. Despite this, e-mobility did not catch on as the decades passed.
My name is Oliver Schwed. I am a transportation scientist and have been a visiting professor for transport planning and politics at the Technical University of Berlin for the last 9 years. We have created spatial structures that can sometimes no longer be accessed other than by car. And so we now have a situation for everyone involved where they are literally dependent on the car. But basically you can say we live in a car society today.
At the end of the 19th century, electric vehicles were expected to replace dirty horse-drawn carts.
In the 1920s, all cities around the world were major metropolises. The proportion of gas, cars, combustion engines and electric cars is each 1/3.
In 1884, a vision emerged. Numerous charging stations within urban areas. Much like our own contemporary discussions, this vision emphasized the need for an extensive charging infrastructure to ensure unlimited mobility.
And the electric car was already considered the city car back then. In fact, these city cars were already largely maintenance-free in those days. And then the idea of a maintenance-free car was stigmatized. They said it was only a women's car, because it's maintenance-free and women don't have to mess with the engine if it breaks down and things like that. Only men can fix and maintain the gas engine. And that was the attitude in the past. And men viewed the internal combustion engine as a masculine challenge.
In 1917, during the First World War, Germany established a committee for standardizing machine components. This initiative aimed to streamline industrial practices, but notably excluded electrical vehicles from the standardization process. This decision had a significant impact on the development of electromobility during that period. In the past, influential lobbies pushing for affordable fossil fuels wielded significant power, while a widespread awareness of the damaging effects of pollution remained limited among the general population.
In the end, the combustion engine prevailed. I think that goes without saying. Yes, for a long time we didn't know at all what negative environmental and health effects the combustion engine would have on such a large scale. Many technical features from the electric car, for example the electric ignition mechanism, have been transferred to the combustion engine. You no longer had to wear out your arm to turn the crank, and the combustion engine took over, and then that was actually the ultimate improvement. Everyone wanted the racing limousine that had everything, one that you could drive 500 or 600 kilometers without stopping. That was the dream and that was the vision. And then that dream was realized.
Price, functionality, safety, range, speed, noise level, and durability were key considerations for both manufacturers and consumers in the early automotive industry. These factors remain important today, alongside advancements in energy efficiency, insulation, and energy recovery. Innovations like mufflers and rubber engine mounts improved comfort in gasoline-powered cars, while affordable gasoline prices made cars economically appealing.
The introduction of mass motorization was a very profound transformation for society, for an urban society. And then, all of a sudden, entire tram systems were dismantled in the 1950s and 1960s to make room for car traffic.
Things have shifted once more. While the world is still grappling with the aftermath of the COVID-19 pandemic, and facing the escalating impacts of climate change, our outlook is changing. We're questioning the role of cars in our lives anew. Can we pursue sustainability while still heavily depending on automobiles? Since 1970, European transport policy has increasingly focused on passenger transport to reduce emissions. In the 1980s, environmental policymakers developed three concepts of sustainability for urban areas: efficiency, consistency, and sufficiency strategy.
The original idea behind sustainable development was that one should pursue all three sustainability strategies equally. Efficiency strategy is probably the one we all know best. The efficiency strategy is to make transportation more efficient, because electric drives are much more efficient than combustion engines. Whatever energy I put into the combustion engine, 30% of it is actually used to power the vehicle and 70% is released as heat. The combustion engine is not very efficient at all. Overall, it's not anyway. We can still improve it, but there are limits. And with the electric motor, for example, over 90% of its capacity is used because of the energy density put into it.
The two strategies that are less popular are consistency strategy and sufficiency strategy. In consistency strategy, production processes are implemented using renewable energies or recyclable materials. The least popular method is sufficiency strategy. As the name suggests, sufficiency strategy aims to motivate people to consume less and therefore use fewer raw materials and energy. Emission levels from urban transportation have remained stagnant since 1990, contributing to an estimated 2 million premature deaths annually due to poor air quality. The impact of traffic congestion is felt in all major cities, underscoring the urgent need for sustainable solutions. In Europe, road transport accounts for 20% of all total emissions. The 1970s was an epoch of paradigm shifts, especially for the transport industry. Public knowledge of an impending climate crisis increased. In 1972, an influential report was published by the Club of Rome, The Limits to Growth. It was a study on the future of the world economy. The report concluded, if the current increase in world population, industrialization, pollution, food production, and exploitation of natural resources continues unchanged, the absolute limits to growth on Earth will be reached in the course of the next 100 years. The Iranian Revolution of 1979 was another major event during that decade that raised awareness about the downsides to a fossil fuel-reliant society. The Iranian Revolution caused energy prices across the developed world to skyrocket, revealing the extreme dependency of these economies on cheap gas prices.
Each year we used 5% more, doubling our demand every 12 to 14 years. Coal production stayed at 1940s levels. Crude oil production dropped. In 1968, natural gas consumption began exceeding new discoveries. Oil companies during this period were encouraged to get oil and gas from other countries. By 1970, we imported 1/3 of our oil and gas, relying on others to meet new needs.
Over time, more roads were built. This means that we have, of course, expanded the road infrastructure that we needed to keep traffic flowing and to organize more and more traffic over ever greater distances more quickly. And that also applies to cities where a city motorway has been built, for example, which is something that was unheard of in the past. And every respectable city that could afford it pursued this infrastructure development.
In 1997, world governments met in Kyoto to address global emissions, setting binding targets for industrialized nations. The agreement, which came into force 8 years later in 2005, set the first internationally binding target values for greenhouse gas emissions. By the beginning of December 2011, 191 countries had ratified the Kyoto Protocol. The USA refused to ratify it in 2001. The United States have remained the largest polluters in the world. In 1990, the U.S. state of California introduced the Clean Air Act, designed to mitigate the increasing air pollution mainly created by cars. This act sparked a wave of hybrid car production there, which would increase the efficiency of the gas-burning engine.
I'm Stefan. I'm currently the CEO and chairman of Beyond. Most of the laws that forced car companies to build electric vehicles was the state of California enforcing certain percentages of electric vehicles being sold, which had to move a lot of the car companies that wanted to sell in this very large vehicle market, California, which is I think the 5th largest individual automotive market in the world. So if you wanted to participate there, you had to invest in electrification. So this was very helpful.
In 2022, the U.S. government passed the most significant climate legislation in United States history, the Inflation Reduction Act. It offers funding, programs, and incentives to accelerate the transition to a clean energy economy. In today's convenience-obsessed world, numerous businesses thrive on the idea of swift transportation. As far back as 1901, manufacturers of electric cars were marketing delivery vans, trucks, and various commercial vehicles in bulk as complete fleets. The COVID-19 pandemic has sparked a revival in electric last-mile transportation, particularly due to substantial growth in the e-commerce sector.
My name is Claudia Vogt, and I am responsible for the commercial vehicles and B2B business for the German, Austrian, and Swiss markets. Ford's strategy is full steam ahead on electric mobility. This means that we will have converted all vehicles for both cars and commercial vehicles to fully electric versions by 2035 at the latest.
My name is Sven Gorka, and I am the branch manager of DHL Parcel here in Berlin. And I would like to say welcome. We are witnessing a transformation. We already have declines in letter volumes and significantly increasing parcel volumes, and that will continue in the next few years.
Wir arbeiten mit vielen, also mit fast allen Logistikern und Last Mile. So we work with many, almost all logistics providers and last mile delivery customers. We have also had a global strategic partnership with Deutsche Post DHL since 2022. And that's not just limited to the delivery of vehicles, but we also work together to define exactly what a vehicle has to deliver for this segment. What does the driver need to make his job easier? Was braucht der Fahrer, seine Arbeit auch leichter zu machen?
The reliance on last-mile delivery services such as Amazon, DHL, and Uber have grown alongside urban population expansion and infrastructure development across the globe.
We deliver around 500,000 parcels per day in Berlin, and at peak times up to 1 million parcels. In addition, there are the packages customers give us that we process for delivery all over Germany. That's an additional 1 million parcels or so.
Last mile hat natürlich ganz besonders.
Last mile delivery obviously has very special requirements because the routes are all relatively short and always have a lot of stops. This is where the diesel combustion engines come in, which actually make up the largest share to this day. Because of this short journey and the fact that the engine doesn't warm up properly, you're a little at your limit.
We don't have to cover long distances. On average, we only drive 10 to 15 kilometers around Berlin, a maximum of 20 kilometers. It's really easy for us to do all of this with one fleet.
Weil natürlich dieses Segment in den letzten Jahren.
This segment has increased so much in recent years due to the pandemic, but also due to increasing urbanization. by 50% in the pandemic years alone. And that is, of course, a challenge, especially for cities because traffic, noise pollution, and exhaust fumes are increasing. And of course, electromobility is an important step forward. The municipalities, the manufacturers, and all partners in this ecosystem must work together so that the delivery service becomes increasingly sustainable and emission-free.
Nachhaltiger und auch emissionsfrei wird.
The last mile sector is one of many facing a radical change. In 2013, 59 billion parcels were shipped around the world. In 2021, that number almost tripled to 159 billion parcels. By 2030, the number of shipped parcels is expected to double to 318 billion parcels. The push for electrification in the transportation sector is also political. The goal is to implement e-mobility throughout every sector in society.
We have several challenges. On one hand, we need to mention that we have to build our own charging infrastructure network. For example, at locations like these. On the other hand, you need partners to manufacture these vehicles in the first place. We have seen in the last 2 years that supply chains have also been very unstable. We had some delays. Now they are stabilizing again. Now we're getting back to the stage when we will be introducing new vehicles again and ultimately taking combustion vehicles out of circulation.
I think that cities have to rethink the way we transport people and we transport goods around cities. We need smart cities and we need to have smart ways to transport. That's why e-mobility is only a small part of it.
The significant increase of battery-powered vehicles in this sector is largely attributed to strategic support from the public sector in stimulating supply and demand. Urban development policies bolstered the adoption of electromobility by focusing on reducing heavy freight traffic, environmental impacts, and inner-city risks.
There are currently 80,000 vehicles on the road worldwide. The big drivers that we also operate and manufacture all have new properties in a climate-neutral manner. And ultimately, a big issue is how we get climate-neutral fuels, especially for the aviation fleet. This is also a research topic. A lot will happen there. I think it's important simply to look at what developments the market will have, so it's less about restrictions, and more about stimulating the scientific development in this area to create progress. And there are some initial approaches. We'll see when it's ready for the market, but development will accelerate dramatically over the next few years.
Wir werden schauen, wann das marktreif ist, aber die Entwicklung wird in den nächsten Jahren dramatisch an Geschwindigkeit zunehmen.
Car manufacturers focused on perfecting combustion engines for decades, neglecting the challenges of further developing better batteries for electric vehicles. In the 1990s, only nickel metal hydride batteries were available, followed by lithium-ion batteries, mainly used in portable electronics. Today, lithium-ion batteries are the most utilized in electric vehicles due to their cost efficiency and performance. This is despite environmental concerns regarding the rare natural resources and carbon-intensive production required for the batteries.
The
vehicles are primarily company tools and have to function so that the work can be done. And that's why the issue of range is of course still one of the biggest concerns for fleet managers. If you're thinking about it, how do I convert my fleet to battery electric vehicles? It is a particular challenge to build the infrastructure both in the company, but also for the employees at home, and of course the expansion of the public charging network.
In our everyday we commonly think of batteries as rechargeable. However, it's important to clarify that traditional batteries, unlike accumulators, cannot be recharged. Accumulators convert electrical energy inside vehicles into chemical energy, enabling them to store and release energy multiple times.
There's a huge improvement in technology by now. You can run many more cycles before the battery degrades. So we expect these batteries to last 5 to 7 years. The used batteries out of the vehicle we use for stationary purposes.
In principle, you can operate the battery for almost 20 years. Ultimately, that's still the issue. How long do the batteries last in continuous operation? Especially in the cold seasons. So that's still the biggest challenge. To be honest, it's no different than a conventional car, which has less mileage in winter than in summer under ideal conditions.
I think the vehicle is more likely to break down than the battery needing to be replaced. So we don't actually assume that the battery will need to be replaced during a customer's life cycle.
The battery significantly influences the value of the vehicle. The older the battery, the lower the resale value of the car.
We don't have any experience yet with battery replacement. We assume a battery lifetime of around 8 to 10 years.
They are lasting much longer than we all thought. I think that many of the companies that have been out for a while with battery electric vehicles have this experience that they're lasting quite long. The raw material itself doesn't degrade in the battery, it's just the battery function degrades, so you can recycle the components of the battery. And this will be a big part of the new business model in a circular economy to recycle this and reuse these raw materials.
Urban mining is the process of reclaiming raw materials from waste products sent to landfills. To reduce our dependence on raw materials for batteries, we need to research alternative technologies, recycle batteries, or improve battery technology. The EU has set strict recycling quotas for used batteries. Starting in 2027, nickel and cobalt must be recycled at a rate of 90%, increasing to 95% by 2031.
Lithium is in many rocks in the world, and you just have to decompose and take the lithium out. We think that over time, the largest source of lithium will be actually recycled batteries, and urban mining will become a large part of reutilizing these raw materials for future battery production.
A potentially disruptive technology, such as lithium-sulfur or solid-state batteries, could replace long-term lithium-ion batteries. The global production of accumulators is mainly happening in China and South Korea. Every service case and every vehicle have different requirements. Batteries for drones have different needs than batteries for e-bikes. The race for the next development is still ongoing.
There's more than one way to do it. There is certainly the idea that you can transport everything on cargo bikes. Then we would honestly be following the approach in Bangkok. But that is simply not possible in Berlin. We have the classic delivery, where we say very clearly, we are aiming for the jumper state with an electric vehicle. We have a huge network of packing stations, which we are constantly expanding. Let's look at the topic of neighborhood delivery in Berlin. Closed neighborhoods only allow limited delivery, for example via micro depots. And we have had a pilot project since last year in which we supply a micro depot across the Spree with a solar-powered boat, along with 2 partners. One is Bihala, who do the loading and unloading. We are the DHL partner branch here in Berlin, and another is Solar Water World, which provides the boat itself.
With electrification, the automotive industry will rely more and more on costly specialty materials, including cobalt, lithium, copper, nickel, manganese, and neodymium. To maintain their competitiveness in the industry, car manufacturers must secure these raw material markets and conduct research into batteries that will make cars viable for the future. The growing demands for e-mobility will also increase the demand for raw materials and its dependence on countries that source them, such as China, which is the leading supplier for battery-grade minerals.
This is still an incredibly wasteful industry, right? Number one, many of the vehicles we build are not being used at their full potential. When you look in cities, how many vehicles are parked and not going to be properly used all the time. Then also the efficiency on how we deliver packages and how we move people, right? With the traffic systems not being smart.
The expansion of renewable energies is critical for electrified, largely emission-free road transport. On June 8, 2022, a majority in the European Parliament called for an end to the production of combustion engines. From 2035, only cars that do not emit any climate-damaging greenhouse gases will be allowed on the market in the EU. In the U.S. state of California, the sales ban is expected by 2035. Only 8 other states in the U.S. are following California's lead. China, the upcoming economic hegemon, is banning sales by 2030.
Unsere Werke haben das Ziel, je nach Standort.
Depending on the location, our plants have the goal of becoming fully climate neutral by 2035.
Also das Werk
So the plants in India and in Turkey will be climate neutral by 2030.
neutral sein.
Here in Cologne, we already produce in a climate neutral way.
Und natürlich wollen wir, dass die Lieferketten
And of course, we want the supply chains to be completely climate neutral by 2035, at least for our direct Q1 suppliers.
Wir haben sehr hohe Investitionen.
We have invested very heavily in our water management, for example, so that we recycle water, use water more efficiently, and we also use solar energy.
Effizienter nutzen, aber auch
We have installed large solar systems on the factory roofs.
Solaranlagen auf den Produktionsdächern installiert.
The main challenges for a widespread adoption of electric vehicles can be broken down into three categories: affordability, practicality, and sustainability. First, affordability is an important reason why we do not see more electric cars on the street today.
Also ein E-Van kostet ungefähr.
An e-van costs about twice or double as much as a traditional van. If it's an LKW, then it quickly becomes 3 to almost 4 times as much as a normal conventional combustion engine.
Eines normalen herkömmlichen Verbrenners.
Depending on the equipment, the Ford Transit model costs just under 60,000 euros in Germany.
Even though decreasing the prices of electric vehicles would improve their popularity, the ongoing financial crisis is instead causing prices to increase.
Wie bei den Wartungs- und Verschleiß.
In the first comparisons of the transit combustion engine compared to the battery electric version, we saw a decrease of 40% in maintenance and wear and tear work. That's expected. There are no significant wear parts in a battery electric vehicle like in an oil vehicle. There is less wear on the brakes. But there are many parts required for a combustion engine that don't exist in an electric vehicle, so they never need to be replaced.
Dadurch halt auch nie ersetzt werden müssen.
And that is, of course, an important factor when considering the overall costs. So, in addition to the vehicle costs, which are still very high in some cases, there are, of course, low costs. When it comes to fuel, that is when it comes to charging, because the charging costs are there, and also in terms of maintenance and wear.
Und eben bei Wartung und Verschleiß vor allem.
In countries like Japan, electric cars and vans are already more affordable than in other parts of the world. Governments worldwide offer incentives to both private customers and companies to purchase electric vehicles. This support aims to enhance visibility and adoption of e-mobility among individual users and throughout entire economic sectors, such as the last-mile delivery industry.
Letztendlich sagen wir, entscheiden die Menschen.
Ultimately, I say we have to let the people decide. How do they want to live, and also what needs to be regulated? Where can you park at certain times? Where are there loading and unloading zones, or where can they be made? But when planning a neighborhood, we set up a micro depot where we can actually deliver the few meters at the end of the supply chain with a cargo bike and reload it sensibly.
The development of electric passenger vehicles is miles ahead of the development of electric trucks. The transport of goods is still dominated by gas-powered trucks and heavy vehicles. The urgency of the issue has caught the attention of many scientists around the world.
When I say sustainable cities and transport development, that needs to be explained. It is nearly impossible to imagine that we can achieve the required standards for sustainable car traffic. There are plenty of studies that have been done on this topic. For example, we would need to reduce car traffic by 50% in all German cities nationwide.
The pressing need for charging stations and the current lack of them is causing skepticism and reducing purchases of electric vehicles. It is essential now to scale up the infrastructure for electric vehicles, and yet the process has just begun.
Für uns ist halt wichtig, das Fahrzeug.
It's important to us. The vehicle is increasingly becoming a smartphone on wheels, through the model we install. The data is collected in the vehicle, but also the vehicle collects data while it is driving and working. The data can be used by the customer to optimize their routes. Especially in last-mile delivery, the routes can be optimized just like the car, just like the packages it delivers in the most efficient form.
Können die Strecken optimiert werden? Wie distribuiere ich die Pakete in der effizienten
Data is particularly important for battery electric vehicles, and this data can be used in a variety of ways.
Diese Daten können vielseitig genutzt werden.
Wir investieren sicherlich in das Thema KI.
We certainly don't always invest in AI. We do have optimal route planning, as we already use it now, to optimally design the routes. But we already use it. We'll see how far we can expand the solar boat, and it always needs to include a partner. You need the infrastructure. That's actually the biggest challenge. Also with the solar boats.
Yes, technology and technical innovation is important. But it's not enough. It is necessary, but it is not sufficient, as the saying goes.
Infrastructure in cities has been continuously developed and redesigned to facilitate the movement of vehicles, especially those that use fossil fuels. Now cities are rethinking their infrastructure to make accessibility better for electric vehicles.
Before mass motorization, the street spaces had a completely different function. Public space was, as urban researchers and urban sociologists often say, a space for encounters in the broadest sense of communication, a place built for the possibility of meeting strangers and then something interesting happening. The public urban space, as we call it, should be accessible to everyone, equally accessible.
One infrastructural aspect that is important for commercial e-mobility is access to fast chargers. Publicly accessible fast chargers, especially those located along motorways, enable longer journeys and can address range anxiety, which is a barrier to EV adoption.
The good news is the real estate for a charger is much less than the real estate for a gasoline. The real estate for a charger is also much more sustainable than the real estate you need for a combustion engine distribution network.
To encourage wider EV adoption, public fast chargers can also provide charging solutions to consumers who do not have reliable access to private charging. In Europe, the overall fast charger stock numbers over 70,000. A fast charger can recharge a car in 30 minutes. An agreement between the European Investment Bank and the European Commission will make over €1.5 billion available for alternative fuels infrastructure. We are still a long way off from achieving a completely electric transport goods industry. The last mile sector needs to diversify their approach with new vehicles for the transition.
The packing station is essential because it really saves on travel. It's also useful for the customer when they live in a residential area and they aren't reachable for some reason. For example, if they're at work and we have no way of delivering to them directly.
Large companies which transport goods to our doorstep, supermarkets, and clothing stores carry a large responsibility to go net zero. Their means of transportation create immense pollution, but they can also afford to make changes. The global share of electric-powered light commercial vehicles is only 3.6%, which is meager when we consider that light commercial vehicles take up 1/4 of the total share of passenger cars. Already in 2020, 80 different manufacturers of electric vehicles were active on the Chinese market.
Also der chinesische Markt ist ja auch insgesamt der größte Automobilmarkt.
The Chinese market is the largest automobile market in the world overall. And of course it is also characterized by the fact that there are many megacities there. And I believe that with these cities and the explosion of the auto industry in China, which is growing as quickly as the automobile market is, the only answer can be electromobility, because otherwise the cities would collapse completely.
Weil sonst die Städte komplett kollabieren würden,
Where CO2 and air quality are concerned, the Chinese government also intervenes in the market with incentives programs and massively supports electromobility.
Mit Incentivierungsprogrammen in den Markt ein und unterstützt die Elektromobilität massiv.
China leads the way in transitioning to an electric society, thanks to robust policy and government-subsidized support from the Chinese Communist Party. This backing has enabled China to adopt electric vehicles at a much faster rate than Western countries. Electric cars and vans are more accessible to the middle class in China compared to Europe and the United States. Moreover, China's investment in infrastructure is unparalleled, with 1.76 million EV charging stations already installed. But could our future also look completely different?
Es gibt natürlich verschiedene Megatrends in der Gesellschaft. Einer ist Urbanisierung und dann gibt es noch viele andere.
There are of course various megatrends in society. One is urbanization, and then there are many others. And of course, when you think of delivery services, you immediately think of electrification, but perhaps also of autonomous driving. Especially in an aging population, it can be an enormous advantage if such services are brought to your doorstep by electric vehicles, and especially in urban centers.
It
It is becoming less and less necessary to own an individual vehicle, I believe it will be a key element to implement a mobility concept in urban centers that consists of many components, where many different providers work together to provide the perfect mobility solution for the individual, resident of the urban center, so that there is much less need to own a car in the future.
Darzustellen, sodass es da viel weniger notwendig sein wird, in Zukunft ein Auto zu besitzen.
Of course, if you live in the country, this will be a completely different challenge than if you live in the middle of the city center. And some cities like London or Paris are already progressing a little faster than we might in Germany.
Schreiten da ja auch schon ein bisschen schneller voran als wir in Deutschland vielleicht.
Singapore is an example where car traffic plays a very minor role. Because the government has simply made it so expensive that hardly anyone can afford a car. And when it's a status symbol, it's desirable, but also not possible for most people to drive around in their own car.
The global consensus is that our future will be powered by electricity. Governments and industries are pouring significant investments into this transition. If we want to preserve our planet, it's crucial for everyone to participate. Industries must take a leading role in bringing this transition to fruition. While electric cars are a significant part of the solution, they're not the sole answer to all our challenges. Their exact role in our sustainable future is still being determined.